Welcome back, everyone. So in this video, we're going to be talking about energy. What is energy? What are the different kinds of energy? And how we can calculate those different kinds of energies. Okay, so first of all, what is energy? Well, it is the ability to do work. Okay, energy is the ability to do work. Now, since work requires movement, you can also say energy is the ability to make something move. Okay? Energy is the ability to make something move. Now, there are lots of different kinds of energies that are out there. There's chemical, which is responsible for, your body functioning the way it does, which it can then convert to mechanical, which is another kind of energy, which is kind of the energy of just us moving things and studying those kinds of things. There's light energy, thermal energy, magnetic energy, electric energy, nuclear energy, so on and so forth. For this video and for most of this course, we're going to be dealing with mechanical energy, right? Which is the energy of me moving it like this, it falling, this going like this. Maybe I compress a spring, maybe something's rotating, things like that. Okay, now, every type of energy that we're going to go through in this video is a form of mechanical energy, right? So sometimes you might get a question like, oh, what happens to the mechanical energy? Basically what they're asking is what happens to these types of energies you're going to see here. Okay, so to start, we're going to start with potential energy. Now, potential energy is the energy of position. The energy of position. So where is an object based on some standard, some initial spot? Okay. Now, with potential energy, we are going to be... Lost my board almost for a second. Looking at two different kinds of potential energy. The first one is gravitational. So gravitational potential energy. Right? And gravitational potential energy depends on height. Okay, so that is the position that depends on. Now, when you say depends on height, it's important to know where you're measuring from. Okay, let's take this board for example, and this marker on the board. Okay, if you were to ask, how much gravitational potential energy does this marker have, you'd have to know, where are you measuring from? Are you measuring from the board? In which case, there's no height above the board, so according to the board, there's no gravitational potential energy. Or are you talking about the ground? Because if you're talking about the ground, well, yeah, this board is above the ground. There's a height. There's going to be some gravitational potential energy. So you've got to make sure that you're clear on that. Okay, so I'm going to do this. PE sub G or U sub G equals mgh. Okay, PE sub G for the Regents folks, U sub G for the AP folks. But no matter what, it's mgh, mass times your acceleration due to gravity times height. Great, and that's that height that we were just talking about. Okay. The next kind of potential energy is elastic potential energy. Right, so that type of energy is dependent on how much a spring is either stretched or compressed. Okay. Now, I'm just going to go ahead and write the equation here. Okay, so again, PES for the Regents folks, U sub S for the AP folks, equals 1/2 kx squared. Now it's a lowercase k that stands for spring constant. The spring constant is a value for each individual spring that basically tells you how stiff that spring is. The greater the spring constant, the stiffer the spring. The lower the spring constant, the less stiff the spring. So for example, the suspension in your car will have a very high spring constant, whereas a slinky, comparatively speaking, will have a very low spring constant. And this x is your displacement. That's the position that goes with elastic potential energy. This displacement is measured from the equilibrium point of the spring. So if the spring with no mass on it is, say, 10 centimeters, and then you put mass on it and now it stretches 5 centimeters, well, the displacement is 10 minus 5 centimeters, okay, which you then convert to meters. Excellent. Now, that's your potential energies. Let's talk about kinetic energy, right? Kinetic energy is the other kind that we're going to be talking about. Now, kinetic energy, two main types, okay? First is translational. Okay, so for kinetic energy, that is the energy of an object that's actually moving. It has to have a non-zero speed for it to have kinetic energy. Okay, translational kinetic energy means the kinetic energy of an object that's moving in a straight line. Okay, so that is Ke, or K, equals 1/2 mv squared. Right, so Ke for the Regents folks, just plain old K for the AP folks, equals 1/2 mass times the speed squared. All right, and the other kind of energy, or kinetic energy that we're going to talk about, is rotational kinetic energy, right? And this is the energy of an object that's rotating, right? Could be a ball rotating. It could be this marker. It could be the planet Earth, whatever. It could be a record player. Doesn't matter. As long as it's rotating, it'll have rotational kinetic energy, right? Which we write as this. K equals 1/2 I being your rotational, or your rotational inertia, times omega squared, your angular speed squared. So rotational kinetic energy equals 1/2 I times omega squared. Okay. And those are the four major types of mechanical energy that we're going to be dealing with. All of their units are joules, just like work, which makes sense since work is a change in energy. Energy is the ability to do work, right? They're interchangeable. So it's very important to understand that they do have the same unit, right? You can say that work is done by changing energy and so on and so forth. We're going to get more into that on the next video, but for now I just wanted to kind of introduce the four main types, give you their equations, and we'll go from there. All right, see you next time.